Hi, welcome back. So in this video, we are going to discuss June 2022, question number 4, Mechanics 1. So a small block of mass 5 kg lies at rest on a rough horizontal plane. So the mass is given, so we need to first draw the weight. Weight, we know W is equals to mass into mass times gravity. So mass is given as 5 kg. So the weight which is acting downwards will be 5g, mass into gravity. The coefficient of friction between the block and the plane is 3 by 7. Coefficient of friction mu is given by the value 3 by 7. Coefficient of friction is represented by the letter mu. A force of magnitude P newtons is applied to the block in a direction which makes an angle of 30 degree with the plane as shown in figure 1. So you can see the force acting here, which is at an angle of 30 degrees. So we need to draw its horizontal and vertical components. So the horizontal component of P will be P cos 30 and the vertical component of the force P will be P sin 30. Now, whenever we have a weight acting downwards, there will be a normal reaction force acting up. Normal reaction force acting up. Now, the block is modeled as a particle given that P is equals to 14. So the force P is given as 14 Newton. So P cos 30 instead of P, I can replace with the value for P, that is 14. So this will become 14 cos 30. And here P sin 30 will become 14 sin 30. Now find the magnitude of the frictional force exerted on the block by the plane and describe what happens to the block, justifying your answer. So we need to find out the magnitude of the frictional force. So frictional force, we know the formula for friction. Since it's a rough horizontal plane, friction will always be acting against the direction of motion. So frictional force, I'm taking it as F. So F will be acting against the direction of motion, so which will be towards left. We need to find out the value for F. We know the formula to find out the frictional force. F is equals to mu, that is the coefficient of friction, multiplied by the R value, that is the normal reaction. But we don't know the normal reaction here. We know the mu value is 3 by 7. So first what we will do is we'll equate the forces vertically. So here the forces acting up, that is P sin 30 plus R is equals to the forces acting downwards. Here we are equating the forces acting vertically. That is, the forces acting up is P sin 30 and R, whereas the force acting downwards is 5G. G value we can always take it as 9.8. Now we need to find out the value for R. So R is equals to, take P sin theta to the other side, 5G minus P sin 30. Now we know the value of P is given in the question as 14. So R will be 5G minus 14 sin 30. So 5 into G is 9.8 minus 14 sin 30. Now when we put this in calculator, 5 into 9.8 minus 14 sin 30, you will get the value for R as 42.05. 42.05 Newton. So now the question is not to find out the value for R, the question is to find out the value for friction. So we know the formula for friction, F is equals to mu R. So we just have to substitute the value for mu and R. So F is equals to mu, it is 3 by 7 given in the question, and R is 42.05. So 3 into 42.05 divided by 7 will give you the answer as 18.02 Newton. So this is the frictional force. This is the frictional force. But in the question, they are asking us to describe what happens to the block. Describe what happens to the block means whether the block is moving or whether the block is at rest itself. So we have studied the condition that the frictional force, if it is greater than the applied force, then the body will be at rest. And if the frictional force is less than the applied force, or if the applied force is more than the frictional force, then only the body will start moving. Here the block will start moving. So here in this case, let's see whether the block is moving or is at rest. We know the frictional force, we just found the value as 18.02. Now we need to find out what the applied force, which is P cos 30 here. So when we substitute the value for P cos 30, which is the applied force acting towards right, P is 14 cos 30. When you put this in calculator for 14 cos 30, you will get the answer as 12.12 Newton. 12.12 Newton. Therefore, here the applied force is less than the frictional force, so the body will be at rest. The block will be at rest. So we can say the frictional force is greater than the applied force. Therefore, the block will remain at rest. Now, the first part is done. It was a 6-mark question. The second part, the value of P is now changed so that the block is on the point of slipping along the plane. Find the value of P. So here, in the first part, the value of P was given as 14. So here, now I need to erase this because we don't know what the value for P is. We need to find out the value for P. Now, in this case, again, P sine 30, and we need to find out the new value of R. When the applied force changes, the normal reaction force R also will change. In the first part, we got the value for R as 42.05 Newton. Now we cannot use R value as 42.05 since the applied force is changing. So we need to first find out what our new normal reaction force is. So R is equals to, we know the forces, I'm going to equate the forces acting vertically. R and P sine 30 are the forces acting up. 5G is what? The force acting downwards. So for the B part, R plus P sine 30, those are the two forces which is acting upwards, is equals to 5G. So I can take, this is new value for R. P sine 30 goes to the other side, it becomes 5G minus P sine 30. This is by equating the forces acting vertically. Now, we just have to go back and see the diagram here. The forces acting horizontally. The forces acting horizontally is what? P cos 30 and F. So, now what we will do is we will equate the forces acting horizontally. So, we have F is equals to P cos 30. We need to find out the value for P only. Now, F, we know it is the frictional force. So, frictional force is mu into R. Mu R is equals to P cos 30. Now, mu, it will not change. It will be 3 by 7. And R, we know it is 5G minus P sine 30 is equals to P cos 30. Now, just substitute. Expanding the bracket, 3 by 7 you multiply with 5G and 3 by 7 you multiply it with P sine 30. So 3 into 5 is 15. 15G divided by 7 minus 3 by 7 P sine 30 is equals to P cos 30. Since we have to find out the value for P, bring all the P values to one side. So 15G divided by 7 is equals to P cos 30 plus minus 3 by 7 P sine 30 goes to the other side. 3 by 7 P sine 30. So I'll take P common outside. So P into cos 30 plus 3 by 7 sine 30 is equals to 15g divided by 7. G value, we know we can take it as 9.8. So 15 into 9.8 divided by 7 is equals to P into cos 30 plus 3 by 7 sine 30. Now, here, what we need to do is, so here what we have to do is multiply 15 into 9.8 divide by 7, you will get the answer as 21. So 21 is equals to P into cos 30 plus 3 by 7 sine 30. Now cos 30 plus 3 by 7 sine 30, you put that in calculator. So let's find out what the value for cos 30 plus 3 by 7 into sine 30. When you put this in calculator, you will get it as 1.080. So 21 divided by, when you cos 30 plus 3 by 7 sine 30 goes to the other side, it becomes division. Divide by 1.08 is equals to P. So just put this in calculator. 21 divided by 1.08 will give you 19.4. So P will be 19.4 Newton. So this is how we solve the question. I hope you have understood this. If you have any doubt, please message me through the chat box. Thank you for watching.